high voltage, you can reduce the current. So based on Ohm's law, where V is equals to IR, if you guys still remember, if I have a very high voltage, that means my I will be small. Okay, and if I use power function, power formula, P equals to I squared R, where power basically is the power loss. If I is small, then power loss is small. So that's the idea lah. Kenapa kita pakai alternating current. So actually few long time ago, there's a war lah between alternating current dengan direct current punya inventor. So siapa yang cipta alternating current? Siapa?
Nikola Tesla.
Yes, very good. So every time kalau kita sebut Tesla nowadays kita teringat kereta kan, but it is actually from the inventor punya name, Nikola Tesla. Nikola Tesla ni is actually Siberian code ataupun Russian, I'm not sure, punya pelarian. Dia lari ke US and they invent alternating current linear generator. And direct current, siapa yang invent? Kalau saya sebut mental, kamu fikir siapa invent?
Thomas Edison.
Yes, actually the same person orang yang invent direct current is Thomas Edison, alternating current is actually Nikola Tesla. So these two person they want to sell out dia punya teknologi lah. Dua-dua cakap dua-dua bagus. So and kalau Edison using direct current, dia actually at one time tu dia berjaya light up a village. Satu kampung tu dapat electric.
Gaduh ke?
Lama. Ha?
Gaduh
Gaduh lah.
dulu.
Gaduh lah. lama pula saya nak fikir. Okay, so Nikola Tesla pula, dia punya idea dia, teknologi dia actually boleh, bukan saja boleh light up satu kampung, tapi dia boleh light up the whole state. So that means different kampung-kampung pun boleh, based on high voltage punya teknologi tu. Dia pakai high voltage and then dia kurangkan power loss. Okay, the thing is about high voltage is that it is actually extremely dangerous. Agree ke tak agree? Kamu agree tak kalau saya cakap high voltage is dangerous?
Agree.
Agree. Okay.
Agree
Saya
je.
tanya kamu, kalau high voltage is dangerous, kenapa monyet yang dekat apa tu? Pernah nampak monyet jalan dekat wire tu tak?
Biasa.
Pernah.
Mati ke tak?
Tak.
Tak. Kenapa dia tak mati?
Potential different.
Pernah jumpa yang mati tak? Betul Ustaz? Pernah jumpa yang mati?
Sebab dia
Tak pernah.
sebab dia
Kalau
tak duduk
burung
time
dia
waktu
pergi
hujan.
Sebab dia tak pijak.
Sebab dia pijak dekat saja. Potential different
Dia
rendah.
pijakkan getah.
Jadi macam
Kamu tak pernah tengok monkey yang mati ya?
Burung pun rasa burung.
Burung mati?
dia kentak ke?
Selain dia
Kenapa nak
boleh
tengok?
mati,
Kenapa nak tengok bangkai?
actually kan, kalau kamu tengok, ada rare cases lah. Kalau monkey tu dia terjatuh daripada tree and then dia sengayut dekat kabel tu, dia actually boleh mati kalau dia pegang dua kabel. So macam betul lah saya nak cakap tu, dia basically tak ada potential different, tapi kalau dia pegang dua, dia akan ada potential different. Basically current tu akan lalu dekat badan dia and dia memang matilah, memang rentung. Ada rare cases. And then the thing about alternating current ni, dia memang sangat bahaya. Sampai ke Thomas Edison ni dia cipta kerusi elektrik. Pernah dengar kerusi elektrik yang pakai untuk hukum mati tu. That one dicipta oleh Edison Cavani pula, Thomas Edison.
So Edison Cavani tu player je. So memang MU je.
Sorry sikit Thomas Edison dia cipta kerusi elektrik tu untuk tunjukkan betapa bahaya alternating current tu. Tapi sebab memang teknologi tu memang boleh pergi jauh, so dia still pergi jauh lah. And the reason why Edison Nikola Tesla ni dia tak berapa nak famous kat US is basically sebab nationality dia. Dia bukannya US punya orang lah. So that's why dia kurang sikit perhargaan dia. Okay, anyway, back to our topic. Okay, sometimes dekat power supply, dia akan tulis 220 volt and 50 hertz. Okay, 50 hertz tu apa maksudnya?
Frekuensi.
Frekuensi, okay. Maksudnya dalam satu saat, current tu bergerak berapa kali? Bertukar direction berapa kali? Dia actually bertukar direction 50 kali ya. So, every 1 second dia akan pergi belakang, pergi depan balik for 50 times. So banyak kali lah. That one is the frequency F. Okay. But how about the 220 tu? 220 tu sebenarnya apa? V kan? Tapi V apa? Dia actually adalah VRMS. Okay. So VRMS ni sebenarnya adalah average. Okay, saya cerita ya. So katakan saya nak lukis voltage that is dependent
Average kinetic energy ke tu?
bukan. V root mean square. Voltage root mean square. Jadi saya sekejap. Okay, kalau saya nak label graph ni as V, voltage dengan time, I can try to draw my graph to look something like this. Okay, it's a sine graph. Okay, let's say my V peak is over here. My V peak I represent as V naught. This one is negative V peak, which is V min lah. So this one is peak voltage, maximum. Sometimes they use maximum lah. In this case is the voltage. Okay. If I want to find my average for this graph, kamu rasa average saya duduk kat mana? Duduk kat sini ke? Duduk dekat sini ke? Or over here? Mana satu dia duduk? A, B, C. Average. Average. Average voltage. Macam mana kamu kira average? Kamu tambah semua kan? Lepas tu kamu bahagi balik dengan semua nilai kan? So kalau kamu tambah semua, dia ada positif, ada negatif. Ada positif, ada negatif. Ada positif, ada negatif. Bila kamu tambah, dia jadi apa?
Kan dia divide into half. So
Okay.
tengah half
Tapi
D.
bila kamu tambah positif dengan negatif, dia jadi apa? Dia setengah. Kalau setengah ni dia dekat mana? Kedudukannya?
Negatif.
Dekat zero. So when we are talking about alternating current punya voltage, the average is actually at zero. Kenapa? Sebab dia ada positif and negatif. So the magnitude tu dia cancel out kalau kamu simply tambah. Okay. So to avoid those, so kalau kita nak cerita, kita tak nak cerita pasal V peak. Because V peak tu jarak sekali-sekali dia dapat V peak tu kan, tapi most of the time dia bukan yang dekat V peak. So kita nak cerita pasal average, tapi kita tak boleh cakap V average. Kalau saya cakap pasal V average, basically semua voltage tu adalah zero. So macam mana saya nak gambarkan V tu? Sebab tu ada VRMS. Okay. So kalau saya ada positif dengan negatif atas bawah ni, macam mana saya nak bawa naik atas? Macam mana saya nak bawa naik bawah ni ke atas?
Modulus.
Apa mathematical? Modulus, okay. Modulus, okay, betul. Tapi modulus kamu masa tak boleh ambil operator tu tiba-tiba macam kamu ada equation, tiba-tiba nak ambil modulus. Macam pelik pula. Selain daripada modulus apa? Modulus tu okay. Ada satu lagi yang kamu boleh jadikan semua nilai negatif positif. Apa dia? Sebenarnya agak gelap. Ambil square. Okay. When you take square, yang bawah tu akan jadi apa?
Positif.
Dia akan jadi positif juga lah. And it will look something like this. So yang down here dia dah gone. So dia jadi positif. So now your graph becomes V naught square. Agree ke tak agree?
Agree, sir.
Okay.
Agree, sir.
Saya betul nak buka mulut ni. Okay, so the average of this graph is actually half of this lah. Kan? So it will be V naught square. Okay, I write it over here. So V mean is basically equals to V naught square over 2. Agree? So if I take the root means take a square root, so I can take both sides. So this one is become V root means square. This is basically that one. V naught over square root of 2. Okay. So basically the position of VRMS. Okay, let's say I turn back to the original graph. Is okay. If you take your calculator, cuba ambil calculator kamu. Can you try to press 1 divided by square root of 2? And tell me what the value is get. 1 divided by square root of 2.
0.70711.
Yes. The value is 0.7071. Eh? That value actually represents 70% of the maximum value. So this is actually somewhere over here. So this one is actually the position of VRMS. Understand? So this is why you have this formula. Okay? The formula here represent V root mean square. Kenapa V root mean square is important? Because we want to discuss about the average VRMS. We cannot simply take normal average because that one would be 0. So this would be the solution to that. So the same thing applied for IRMS. So I can write this one as I naught over square root of 2 as well. Okay. Okay, so that's about VRMS dengan I naught. VRMS ni is a bit tricky lah. VRMS dalam soalan, sometimes this one is called as average, jarang-jarang lah. Tapi maybe disebut average supply. Katakan dia kata voltage supply itu represent that one is actually represent VRMS. I'm bring this one forward because they normally they will use supply voltage. So average jarang. Lagi satu yang selalu dipakai adalah V source. Okay, this is the term that they use lah, compared to peak dengan max voltage. Okay, bezakan between this one and this one. Okay, the thing about voltage dalam chapter ni ada banyak, ada quite few lah. Kita ada V naught, VRMS, and then kita ada VC, VR, VL. So this is the first step yang kamu kena bezakan. Okay, so far ada soalan tak?
Tak ada, sir.
Belum.
Ada. Belum. Yusof, okay Yusof. Saya dah tak dengar.
Okay.
Okay. The next part is actually if you want to discuss. Okay, sebelum saya skip, saya nak tekankan something sebelum saya skip. Okay, this graph actually saya boleh represent with a equation. V equals to V naught. This time dia adalah sin lah, omega t. Okay, kenapa sin? Because the shape is sin. It depends on the shape lah. Kalau ada cos, dia jadi cos. Omega is actually equals to 2 pi f. Frekuensi dia. Kalau frekuensi dia 50 Hz, masuklah 50 Hz dalam tu. Okay. Sometimes kamu boleh pakai juga sebagai 2 pi over t. Jarang-jarang lah, but maybe you can use. Okay. V naught is V naught, the maximum. Biasanya dia akan kasih VRMS. So you have to find V naught lah. You can rearrange this equation. V naught equals to VRMS multiplied with square root of 2. And then you will get V naught. And then you can substitute inside here. The same thing I can write about my current I. Okay. And you might have to use this one if the question asks you to find voltage and current at specific time. Okay. So this one is actually dependence on time. So normally dalam syllabus kamu, dalam soalan exam, dia akan bagi pada few parts lah. Soalan yang pasal VRMS ni, dia boleh jadi dalam dua bentuk. Pertama, dia tanya dependence dengan time. sama ada dia kasih graph, and then you have to use this formula ataupun kamu kena write this formula, and then you can find the V after 3 second ke contohnya, itu satu bentuk. Okay, lagi satu bentuk, they give you a circuit and they want to find voltage across the certain component. Okay, so we're going to look into that now. Okay, for your syllabus, kita ada 6 type of circuit. Banyak kan? Banyak tak number?
Banyak je sir.
Okay.
Pusat saya.
Okay, the good news is that semua ke-6 circuit tu adalah in series. So dia tak ada parallel lah, tak macam capacitor dan resistor direct current ke apa tu. Okay, that's the good news. Bad news saya tak ada. Okay, notice that I draw this one as my macam ni kan, macam ombak tu. Itu represent alternating current punya power supply. So the first three actually here represent pure R circuit. Okay, pure capacitance circuit. Okay, boleh tak? Malas dulu. Pure inductor circuit. Okay, maksudnya dalam satu circuit ni ada satu komponen je. Komponen tu maksudnya satu komponen lah. And then you have 3 more, that is a combination of this. So setiap combination tu dia mesti kena ada resistor. So resistor wajib ada. And then dia boleh combine, contohnya ni dengan kapasitor. And then we have a resistor combined with inductor. Ini inductor. And then we have resistor, inductor, and capacitor. So all 3 combined. So this is what we call RC circuit. Okay, RL circuit and RLC circuit. Okay, biasanya nama ni tak penting sangat lah, because normally the question we state ada berapa dalam tu instead of nama dia. Okay, biasanya soalan ni memang kasih satu-satu je, so tak susah pun. Okay, the thing about voltage dan current ni, so dalam direct current, kamu hanya ada satu magnitude. So the current is constant, tak ada masalah. Okay, but in alternating current, the voltage and the current keep on changing direction as well as their magnitude. Okay, so because of the change in direction, you will expect at certain component, voltage dan current ni dia tak bergerak together. Dia tak bergerak sama-sama. Okay, kamu jangan susah hati pasal lecture notes kamu ni. So lecture notes kamu a little bit complicated. Nampak macam complicated eh. So what I'm going to do now is that I'm going to write you a phasor diagram. Okay, nama dia adalah phasor diagram. Phasor diagram ni to indicate kamu punya position of voltage dengan current at specific time. Contohnya, saya ada current dengan voltage, dia gerak. Saya nak tahu siapa yang datang dulu. Current dulu ke voltage dulu. Berapa beza angle dia. So we use a phasor diagram. So my phasor diagram, remember mine is slightly different than your lecture notes. I always put my current to be to the right. Okay, current saya sentiasa ke kanan. Okay. Okay, make sure you label arrow with the symbol. And then the direction of phasor diagram tu actually adalah anti-clockwise. So this is the direction of the omega. Macam mana nak baca kan? Dia anti-clockwise. So phasor diagram ni, for me personally, you need to know how to draw. Sebab kalau dia tak suruh draw pun, you still have to apply. Dan lepas ni kamu nak kena apply with the phasor diagram lah. From the phasor diagram. Okay, now about the voltage. Okay. Okay, the voltage here, if I have a pure resistor, current dengan voltage akan bergerak together. Okay, this is actually VR, tapi sebab dia tak ada V lain pun, this one is basically just VRMS. Sabarlah, tak kisah nak tulis mana-mana pun boleh. Kalau kapasitor, okay, kalau ikut logik kapasitor ni, before you have a voltage across the capacitor, you need to have the current first. So current ada, current akan push all the electrons and everything, and then only you have a potential difference between the two plates. Okay, so basically you need to have current first, and then you have V capacitor. So basically current will lead capacitor punya voltage. And then the last one is about inductor. Inductor dia datang dulu. So saya ada masalah L dengan C saya very similar. Okay, for inductor, you can imagine when the current want to reach the solenoid, they will produce a change in magnetic field. Okay, so because of the change of magnetic field, there will be induce of EMF according to Lenz's law lah. So this is how you, if you want to think about logic. That's why VL comes first before current. Okay, if you're talking about logic, huh? But if you want to memorize, okay, paling senang cara nak memorize is about, normally saya pakai langit, cacing. R ni tak ada, rumah kot. Okay, so basically kamu punya langit dekat mana? Kat atas. So dekat atas. Cacing kat mana? Cacing kat mana? Kat bilik air kamu.
Tanah.
Cacing kat bawah.
Cacing kat bawah Okay, so cacing kat bawah lah, dalam tanah. Memang ada cacing kat luar, tapi tak nak lah kisah pasal tu. So cacing kat dalam tanah, down here. Rumah dekat atas tanah. So over here. Okay, bawah, atas, atas mendatang. Dengan syarat your current mesti dekat sini. Current kamu kat atas tanah lah. So the thing about lecture notes kamu, dia pakai I dia tu bukannya dekat fixed point. So dia akan jadi a little bit confusing kalau kamu compare dengan lecture note. So dia sama je sebenarnya. So saya ulang langit, cacing, R. Okay, now we try to look at the RC, RL and RLC. So the concept is still the same. VR dia ke mana? V across the resistor. Kiri, kanan, atas, bawah. Ya. Yeah. Hello.
Kanan.
Mana direction
RCR dengan RLC sama je?
Sama je dia susunan, tak kisah.
Okay.
Okay, soalan saya dekat saya punya RC circuit, VR saya ke mana dalam phasor diagram saya? Okay, jangan tengok nota kamu. Ingat apa yang saya cakap tadi. Langit ke mana? Atas. Cacing ke bawah. Kalau R?
Kanan.
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 Atas. Kanan.
So this one should be VR. Okay. Yang this one is actually my VC. So VC tu ke mana?
Bawah.
Bawah.
So I have VR to the right and VC downwards. Okay. Kalau kamu cerita pasal direct current, if you want to find my V terminal, you can simply add V1 tambah V2, betul? Tapi here, the VR and VC, VR and VC does not move together. So you cannot simply add macam tu. So you have to consider that this one is a vector. So if you want to find the sum of a vector, basically, VRMS saya would be in this direction. Agree ke tidak?
Tak faham sangat sir.
Tak faham Okay, kalau direct current, if you have more than one component resistor kan, macam kamu ada multiple resistor, 1, 2, 3 resistor. So if I want to find my V terminal ataupun V source dia tu, basically I just add V1 tambah V2 tambah V3. Betul? Betul ke tidak? Okay,
Ya.
now since we are
Betul.
talking about VR and VC for alternating current, so VR dan VC ni dia tak bergerak serentak tau. Maksudnya maybe dekat sini dia maximum, VC tu pula tengah minimum, VR ni minimum, ini pula maximum. So they don't actually move together. Actually they differ by 90 degrees. So seorang tu tengah nak maximum, seorang tu dah minimum. So you cannot add. Simply add lah. So you have to consider about the direction as well. So if I want to find the resultant of VR and VL for a vector, so ada direction kan, it will be a Pythagoras over here. Faham tak? So if I were to write the equation, my VRMS will be VRMS square equals to VR square plus VL square. Take the square root. Okay, before this dia tak ada masalah sebab you only have one component. So your whatever the voltage across this component is basically your source. But here you have more than one component. Okay, if you want to find the source VRMS, you have to consider both. Okay, now for this one, you have VR. Ke mana VR direction dia?
Kanan.
Okay, good. Oh, better. VR ke kanan, VL naik ke
Atas.
mana? Ke atas. Good. Okay, so similarly, now VRMS will be in this direction. Okay. So if I were to write the equation, my VRMS now becomes VR square plus VL square. And take the square root. Okay, now RLC circuit. VR saya ke mana?
Kanan.
Kanan. Saya tanya banyak kali kan? Saya tanya lagi. VL
Atas.
atas. VC bawah. Okay, so VRMS saya dekat mana pula? So dia sama ada dia ke sini ataupun ke sini. We never know unless we know the values of VL dengan VC. Kita tak tahu pun sebab kalau VL tu besar dekat atas lah. Okay, kalau VC tu besar dekat bawah. So it depends on those value. So if I were to write, so it will be VRMS square root of VR square sama juga tambah VL minus VC. Kenapa VL minus VC? Because yang atas ni saya tolak yang bawah tu. Lalu saya dapat tinggi dia ni berapa. Faham tak?
Kenapa kita kena tolak tu?
Okay, sebab satu tu ke atas, satu tu ke bawah. So, macam saya cakap lah, kalau saya nak tengok VRMS dekat mana, dia basically yang ni akan sama ada bawah tolak atas ataupun atas tolak bawah lah. So, kamu akan dapat sepatutnya dekat mana? Dekat sini jika yang y axis lah. Dia vektor kan?
Faham.
Okay. So, actually, if you want to use the formula, you can straight away tengok yang ini je. So, tadi saya dah ajar cara macam mana nak hafal langit, cacing and rumah. Now, how to use this one is basically, if you only have two component, that means you have R and C, yang VN ni kamu boleh tutup dengan tangan. So, if you close with your hand, you are left with VR square plus VC square, which is this one lah. Okay, so basically you don't have to memorize anything pun. As long as you know how to use this formula, then it should be okay. Okay, and then you have one important quantity, okay, that we call a phase angle phi. Okay, the phase angle ni is actually the angle between V and I. Okay, so in this case dia adalah VRMS to be exact. Okay, so in this case it will be here, here, and there. Okay, tidak? Ini baru position lah. So yang ni adalah 90 degrees, kamu boleh nampak lah. So actually over here you can see that current leads VC by 90 degrees. Okay, in this case voltage leads current by 90 degrees. Okay, this one you have to calculate phi dia tu. Kamu boleh pakai cos phi ataupun tangent phi, it doesn't matter because this one is basically just your trigonometry segitiga. Okay, ada lagi satu quantity yang important. So if you guys still remember, for direct current we use V equals to IR, betul tak? Kalau saya pakai ini sebagai V terminal, I tu I lah, R tu saya kena pakai R efektif. R efektif maksudnya apa?
Total.
Yes, total resistance of the circuit. Maknanya mesti V terminal. Yes. Yeah. So in this case, untuk yang first pure resistor, V RMS equals to I RMS. Ini apa? R lah kan? Sebab total resistance in the circuit is the resistor. Boleh faham? Okay, kalau yang this one V RMS equals to I RMS, saya nak tulis apa pula? Resistance. Okay, resistance across the capacitor, we call that one as XC. Okay, unit dia masih lagi ohm. So it is basically just a resistance, but they use the term XC that we call capacitance reactance. Okay, so this capacitance reactance you can calculate using formula of XC equals to 1 over 2 pi FC. It depends on the frequency. The higher the frequency, in this case, the values of resistance will be lower. Kalau kamu nak bayangkan di kapasitor, the frequency tu banyak sangat. So the across the capacitor tu macam dah tak terasa dah. Something like that lah. Okay, for this one, for pure L, boleh buat kat sini. Okay, if I were to write V RMS, maknanya dia mestilah I RMS XL, reactive inductance. So the XL is equal to 2 pi FL. Okay, so far ada soalan ke tidak?
Tak ada so.
Tak ada.
L tu apa?
Apa?
L tu apa L? Yang 2 pi FL.
LL. 2 pi FL. Di sana memang sing. Okay. Anyway. How about my RC circuit? So kalau saya nak tulis V RMS equals to I RMS, ini saya nak tulis apa? Kalau R efektif, kita tulis R efektif lah, total resistance. Tapi untuk syllabus ni kita ada Z. Z tu apa?
Impedance.
Yes. Okay. Z is actually impedance that is represented by the symbol Z, and it is actually has the same unit with resistance which is ohm lah. Dia adalah total resistance in a circuit. Okay, so whenever you see a circuit that have more than one component, which is most likely that the one that you will see in exam. More than one, straight away you use this one. B RMS equals to I RMS Z. Okay. How do you find the values of Z? Z actually comes from the formula Z equals to R square plus XL minus XC square. Okay, if you look straight away, you will see the resemblance between these two. Sangat sama. Z, R, XL dan XC. In fact, dia derive daripada sini. Okay, how they derive it? V equals to IR, V equals to IR, V equals to IXL, V equals to IXC. Because all of these called I is they have the same value because it is a series, so you can cancel out all the I. So tinggallah yang bawah ni. Okay. In fact, you can also write the equation of the phasor diagram in terms of the resistance itself. So saya boleh tulis dia sebagai R XC juga. Yang ini adalah dia punya Z. Itu tak ada masalah. Dia memang directly correlated like that. Okay. Ada soalan tak? Okay, tak ada. Kalau tak ada, maybe kita boleh berhenti kat sini dulu kot. Kami cuba buat lecture notes dalam kurang lebih 2 hours kan after this. Try to do your tutorial. Okay, jangan lupa kita ada UPS next week. Okay. Thank you everyone.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Baru dengar suara.